All right, we're going to end this chapter with a fairly simple and straightforward process solving absolute value equations. We had rational equations, which were equations with fractions, radical equations, which had square roots, and now we've got absolute value equations, which have absolute value. Now, you know the absolute value is just a number made positive. That's the way most people think about it. You get the absolute value of -3, you just turn it into +3. And that's a perfectly reasonable way of thinking of it, but it's not going to work for us here. We need to think of absolute value of something as being the distance that it is from 0 on the number line. So in order to solve this equation, we need to find all possible values for x whose distance from 0 is 5 units. And you already know the answer here. If we start at 0 on the number line and we go 1, 2, 3, 4, 5 units in the positive direction, we'll be at 5. If we go 5 units in the negative direction, the only other direction to go, we'll be at -5. So those are our two solutions. X equals positive or -5. And this is the key to solving absolute value equations. Here we've got one that's a little more complicated. We got the absolute value of x plus 1 equals 4. Well, the absolute value of something is its distance from 0 on the number line. So in this case, x plus 1 is either going to be equal to 4 or x plus 1 is going to be equal to -4. Whatever's in the absolute value sign is going to be equal to the positive version of that or the negative version of that. And that gives us two little equations to solve. They'll both have the same process for solving them because this thing is the same as this, right? X plus 1 is going to be in both of them, and we need to subtract 1 from both sides. So we get x is equal to 3, or here we'll subtract 1 from both sides and we'll get -5. This part's easy. The only place I see, well, there are two places I see people messing up here. One of them is they just get rid of the absolute value, which tells me that they haven't really been paying attention or practicing, and I don't have much sympathy when I see that. The other one will come up in just a second. So let's do one more. Absolute value of something is equal to a number, which means that thing, the 3x plus 2 in this case, is equal to either the positive version of that number or 3x plus 2 is equal to the negative version of that number. Notice this thing doesn't change. It's 3x plus 2, 3x plus 2. It's only the number on the right-hand side that we get positive in one equation, negative in the other. And then we solve. Subtract 2 from both sides, we'll get -1, and then divide by 3. We'll get -1/3 there. And here we'll subtract 2 and get -3. Divided by 3 is -1. So our two solutions are -1/3 and -1. The only other mistake I see, and I'm not going to write it because I don't want you to ever see it on your paper or mine, would be to deal with this by changing this to 4x plus 3, to just make everything under there positive. I don't understand that at all. It's nothing at all like the way we solve it, but I see that every once in a while. Just like with the radicals, we have to isolate this. Before we can do this step of breaking the one equation into two, we need to make sure we have the absolute value alone on one side. So here, isolate the radical by subtracting the 1 from both sides, and then we can break it up. That thing stays the same, right? So it's just exactly like the equation without the absolute values. And we got the second one. The left-hand side's the same, and the right-hand side is negative. And the steps for solving these are not college algebra level. We add 3 to both sides, we get 9 there divided by 4. So 9/4 is one solution. Add 3 to both sides, we get -3. -3/4 would be the other. I know you know how to do that process, so I don't need to write it down. And that is the end of the chapter.